Action. I should probably keep that in there.
Well,
Not now. There's awkward silences. Balancing
Exactly.
equations, part 2. We're going to do word equations. Guess what? This is everything. There's nothing new in this podcast. Well, okay, I lied. There's one thing new. However,
most of it's stuff that we've already done before, but just putting it all together into
Yeah. except
what
it's,
we really do
it's
in
really
chemistry.
it's everything we've done over the past month.
quarter and a half.
There's a lot in here.
Not really.
You got to pay attention. When you have words, you need to first write the formulas. When I say the word sodium nitrate,
What does that mean?
Na is positive 1, NO3 is negative 1. You flip the charges, you balance it, you write the formula.
So we need to remember all that stuff about how to write formulas?
Yeah,
named-
there was a purpose
names?
to that, actually.
really?
Because you're going to mix two different chemicals together. So if I said sodium nitrate and lead chloride, you would write both formulas down and see what happens.
And you thought you didn't have to do naming and formula
No,
writing
you're
anymore.
gonna, it's all year. Now, the key to this, to not get confused, is to write lines for coefficients because the formulas do not have to be balanced.
Yeah, as words, you're writing it out from words to formulas,
And
it's
then
not necessarily
you
balanced.
You balance
Yeah.
the equation after you get all the formulas
So
correct.
yeah, basically you always want to leave a space to do the balance.
And then you balance it like we've been doing. The new addition is you have to include states of matter. This gives us a little bit of information as to whether or not they're solids, liquids, or gases, or aqueous.
So the point of chemical equations in the first place is to be able to communicate from one chemist or one person to another, and adding these states of matter just is one way to help us communicate how this reaction actually works.
Are they mixing solids together or liquids? I just don't know unless you put the states of matter. Aqueous is a new word we have not come across before. This just means a solution. So you have essentially a solid dissolved in water, and that gives you an aqueous solution.
That makes sense. Water, agua, in
Agua,
Spanish.
aqueous,
Yeah,
yep.
all right.
However you want to remember it. That's a good way to remember it, though. So here's an example. There's a lot of words here. Don't get flustered by all the words. Only pull out the information you need. First, you have to figure out what's actually going on here. Silicon dioxide reacts with aqueous hydrogen fluoride to form gaseous silicon tetrafluoride and liquid water.
Ah, that's so much.
So, pay attention to key words. Reacts with, plus. You have underline your formulas you need to write. Silicon dioxide plus hydrogen fluoride is going to form.
The arrow, we use the arrow for
It's
form.
going to form products.
So you're going to see a couple different words for that arrow. Form and yield are the most common.
Yield produces.
Produces too.
This
yes, right,
plus
right.
this form gaseous silicon tetrafluoride and water. You can see, and water plus water. You can see how the balanced equation, the general structure is still here in words. So let's write each formula we come across individually.
So silicon dioxide looks like it's the first one. We're going to leave a space so that we can balance it. And silicon dioxide,
SiO2. Plus hydrogen fluoride.
Hydrogen fluoride, that sounds like an ionic compound made
Hydrogen.
up of hydrogen.
Now I'm gonna go back here. I know that's ionic. Hydrogen is +1, fluorine is -1.
All right.
Switch those charges.
1-to-1 ratio.
HF.
It's an easy one.
Silicon dioxide, we should have said this is covalent. One silicone, mono, it's not there. Dioxide, 2 oxygens. SiO2 plus HF, ionic, is going to make silicon tetrafluoride.
So that's another covalent compound because you can see the prefix there.
And tetra means
4.
4.
Tetris, you know the game.
And
Like we've been
water. And the formula for water is H2O. You know that. And then from there, notice my molecules aren't balanced. I did each one individually. Just silicon dioxide, just HF, just silicon tetrafluoride, just water. There are 4 fluorines on the left, or the right, products, and there's only 1 on the left. They do not have to be balanced right now. That's what the lines are for. Get all your formulas written just like you have all year, and then balance them. We're going to try and do these without an inventory and see how you can do just kind of keeping track of them in your head or one by one.
When I look at this, I look at the silicon first because it's the first element in there. So
All
I
right.
look at it on the reactant side, and I look at it on the product side, and I see there's the same number of each. There's
All right.
one of each.
Silicone's good. I'll write a little checklist. Silicone's
Cool.
good, 1 and 1. Let's look at the oxygen next. It comes next. You're just picking atoms going back and forth. 2 oxygens on the left, 1 on the right. So let's put a 2 there. Now I've got 2 and 2. The oxygen is good.
Okay, moving on to hydrogen.
Hydrogen,
We got
1 on the left, 2 and 2.
4.
4, 2 times 2 is 4, 4 on the right. So I
Yep.
need 4 on the left. How do I get that?
So we need that coefficient of 4 in the reactants.
4 in the reactants.
Great.
All right, that's good. And the fluorines,
Well, we put that 4 there for the reactants.
4
so
on
it
the
means
left,
We have 4 now.
4 on the right. Look at
Oh,
that, it works.
Fluorine is already
Now,
balanced.
Mr. Giacomo, we said all that. We gave him all this new information, and what did we forget to write?
We forgot to write the state symbols. Or maybe we were just saving them for
The
last.
phases. We planned this. Solid silicon dioxide. Hydrogen fluoride is aqueous. That is a solution. Don't
AQ.
forget these. Silicon tetrafluoride. That one's a gas. And these phases, they're kind of like subscripts after the fact. And H2O, that is a liquid. So we write that
Nice.
liquid off to the
We
side.
got all 4 of them in this one equation.
Wow, I didn't even mean to do that. But it happened. So back and forth, balance them. Don't forget the phases. Write each formula separate.
And we're good.
And we're good. It sounded like I had something else to say there. I didn't. Example number 2. Let's
Okay,
go
we're going to
through.
break it down again, underlining
Lead.
each compound or each species, if you will. Right?
Lead 2 nitrate
feel like
reacts with sodium to produce sodium chromate and lead to produce. There's that produce arrow. This plus this makes this plus this. All right, let's
All right.
write them in. Start with the lead nitrate, Mr. Giacomo.
Lead nitrate. Lead looks like it has a +2 charge because there's
It
a Roman
does.
numeral 2
Nitrate, I know, is -1. We flip
on
those.
the polyatomic ion list.
Lead, nitrate, there are 2 of them. That is aqueous. I'm going
Good,
to put
we
it
have state
first
symbols
this
in there
time, just
now.
so you can see what it looks like
cool.
to do it first.
And then it reacts with solid sodium. What is
So
sodium?
Na, right? Well, sodium is Na. There's a line for that.
Oh, it's just the element Na. That's
Na,
easy.
sodium.
Cool.
And it's charged +1, right?
No, it's just the element though.
Oh, it's by itself.
Yeah.
It doesn't say ion. It is not an ion. It is a neutral element. So it is just Na, nothing else. That's a solid. It's going to make aqueous sodium chromate. Now it's an ion because it's combined with something else. There it's +1.
I'm a little curious about this reaction. Where
Chromate.
does chromate come from?
Weird. Let's
I think that was supposed to be nitrate.
nitrate.
There we go.
We just made matter. Nobel Prize. Sodium nitrate. Sodium is +1. Nitrate is still -1, same as it was over there. So +1, -1. I need 1 sodium and 1 nitrate. You guys should be really good at this point.
That's also aqueous, so we put that little AQ symbol there.
And now I'm going to get lead.
Solid lead.
Regular. No ions, no charges. It's a solid.
All right.
Nothing has to be balanced yet. Wait until you get all the formulas right and then balance the equation.
Okay, so it looks like we got all the formulas right, so we can balance now.
We can. I'm just going to kind of come as I see them. Lead,
Lead's good on each side, looks
1
like.
and 1.
Yeah,
Lead
good.
is good.
Check that one off.
Nitrate,
2.
2 nitrates,
2 nitrates.
polyatomic, keep them together.
The other side, it looks like we only have
1
1.
nitrate, coefficient. Now I have 2 nitrates.
Okay, so now the nitrates is all set.
Those are good. And sodium, Na.
So 1 sodium on
1
the
here.
reactant. Yeah.
2 here on the right.
So we need a 2 coefficient there, just 1 sodium by itself. That's really easy to do, makes it nice and balanced.
And those are good. 1 lead on each side, 2 nitrates on each side, 2 sodiums on each side, and everybody's happy. Especially me, because we're done recording the podcast.